The next pre-calc topic is quadratic functions, and we'll define a quadratic function like this, where we have numbers a, b, and c, and this notation says that the variables a, b, and c are elements of the real number line. So these are any real numbers with a not equal to 0. And then we use these three real numbers and put them in a polynomial with highest degree 2, which then this is a quadratic function. Now the general shape of a quadratic function is if a is positive, then it opens up. Now it could be anywhere on this coordinate system, depending upon the functional translations that happen. And if in general, if a is negative, it opens down. This quadratic term ends up dominating this function, and so that's why this one number determines the shape of opening up or opening down. Now a couple more definitions that we're going to look at are the axis of symmetry and the vertex. Any quadratic function you can flip-flop back and forth along this axis of symmetry, and this half will be the same as this half. You flip them and they go right on top of each other. Okay, so this is called the axis of symmetry, and in this example, at some point there's a lowest number and then it starts to go back up, and that lowest point is called the vertex, and then we'll find how to find those. And the vertex is also, in this example, at some point it'll get larger and larger and larger, then it starts decreasing, and then that spot is called the vertex, and it also has an axis of symmetry. So let's start looking at the standard form of a quadratic. Now in one of my previous videos of function translations, you would instantly know that the parent function of this is a quadratic. It's a x squared. And then this would be a horizontal shift, this is a vertical shift, and this is what's called a dilation, so it shrinks it or stretches it. And you'll have to look in at one of my previous videos to get a better understanding of that. But we wanted to look at the vertex and the axis of symmetry. So now when we plot this is the horizontal shift, of course depending upon if it's positive or negative, and we'll assume that it is shifted at this much and k goes up this much. Well, that point right there is the vertex. So HK is the vertex of that, and H is the axis of symmetry. So if we're to, of course my bad graph, though it doesn't look symmetric, but that's the axis of symmetry, is at H. And notice that if A is positive, it opens up, which means that vertex is what's called a minimum of that function. Now if it were to open down like this, that vertex would be a maximum, and that's what this says right here. Okay, so this right here is the standard form of the quadratic, but not every quadratic we see is in this form. And matter of fact, the definition, if we looked at, had it like this. So there is a way to take every quadratic and, I'm going to say, trick it or manipulate it into the standard form. And that's what we're going to do next, and it's called completing the square. And I'm going to illustrate this with a few examples first. So if we have x minus 3 squared, that's the same as x minus 3 times x minus 3. And then if you were to use the FOIL method for this, you'd get x squared minus 6x plus 9. Okay? And one note is that if we look at 9, it's actually minus 6 divided by 2 squared. So minus 6 divided by 2 is negative 3, Negative 3 squared is 9. And that's actually a general rule, and we'll look at that more specifically in a second. So, if we're given this example here, x squared minus 6x plus 8, okay? If we were to add 1 to this and subtract 1, which is what we do here, so what we've done was add 0, right? So this piece is the same as this piece. 9 minus 1 is 8, which is that. So we actually haven't changed this equation any. And the reason that we do that is this piece here looks a lot like this piece. So we can square this. And that's what we do. So we take this quadratic, we do what's called complete the square. So find some number, that makes this a perfect square. And then of course there's going to be a leftover. And then we get this. Now, you might ask, why do we do that? Well, the reason is that we're taking quadratic equations and then learning how to put them in a standard form. Okay? So let's look at even a more generic equation. And that is this one. So we have x squared plus bx plus c. Okay? Now, what we're going to do is add what's called a well-chosen zero to this. We're going to divide this number by 2 and then square it. So if we add it, then we have to subtract it. So this piece is the same as this, because if you think about it, we've just added 0. But the reason we do that is this piece here becomes a perfect square, and then we have what's left over. And what's left over is a number, right? B and C are numbers, or they're real numbers. So a real number divided by 2 squared, and C, that arithmetic is a number. So this piece becomes a square, and then this becomes a number. So to a generic quadratic equation, this is the horizontal shift, and this number is the vertical shift. Okay, so let's follow up on this one more time, and then we'll give some examples. So if we look at a generic, totally generic quadratic equation, where we have a coefficient here. In the previous one, that was just 1. So if we factor out an a of each term, we get this. And if you take a times this, we get that number. If we take a times this, well, the a's cancel and we're just left with bx. A times c over a, the a's cancel, we just get c. Now this becomes something that we can complete the square on. Okay, so here we divide this by 2 and then square it. So b over a divided by 2 squared. And if we add it, we have to subtract it. So we've added 0 right here. And then every piece is just the same. We've added 0. Okay, now we're going to group this. This is one group, and this is another group. We can put parentheses around it. Okay, so we put parentheses around this to get that. And remember, a is times the whole thing, so I put square brackets to emphasize that. And then here, I just move the CA first and then subtract. Okay, well, we have one term, we have a second term. Now we're going to multiply a into each of those terms. So we got a times this term, which is this. And then we have a times this term, which is this. Okay? Well, we chose this number because it makes a perfect square. So this factors into this, x plus b over 2a. Okay? And then if we multiply the a in, the a's cancel, leaving c. And if one of those, if we multiply the a into here, it cancels with one of the a's and leaves that. Oh, and the step from here to here is we just square. So it's b squared, 2 squared is 4, a squared is a. So that's how we get from here to here. And then from here to here, we multiply the a in. Okay? So now, this isn't quite in standard form. And the reason I say that, okay, this is a number, and it kind of looks like the standard form, but the standard form has a negative there. So what I do is I put a negative and then minus b. So minus a minus is plus. And then that tells us that this is the horizontal shift, and then this is the vertical shift. Okay. So wait, if that's the horizontal shift, that tells us the axis of symmetry. So the axis of symmetry is at minus b over 2a. So that's how far the graph is shifted. So this is the actual x value. And then the vertex is at the axis of symmetry, and then the height is this vertical shift, which is that. So this is the formula to find the axis and the vertex. So let's look at an example here. So we have f of x is equal to this function. We want to find the axis of symmetry, the vertex. We want to know, is the vertex a minimum or a maximum? And then we want to graph it. So the first one, the formula for symmetry, x is at minus b over 2a. So we start plugging in this. B is 2, so that's minus b, which is minus 2. We have 2, and then a is minus 1, so that's this. So we have minus 2 over minus 2, which is 1. So this has been shifted. If the parent function is a quadratic, it's just been shifted over to the right 1 unit. Now the axis of symmetry is this formula, minus b over 2a, c minus b squared over 4a. Well, this we just calculated, so we put it there. And then c is 5 minus 2 squared, 4 times minus 1. And then that's 4 over minus 4, which is minus 1. So we have 5 minus a minus 1, which is 6. So the vertex is at 1, 6. So then the next question says, hey, is this a minimum or a maximum? And the answer is, since a is minus 1, which is less than 0, which means the quadratic opens downward, then that vertex has to be a maximum. And then the next says graph it. Okay? So the vertex is at 1, 6, so we go over 1 and up 6, and it opens down. So that's the general shape. Okay? But there's one more page, or one more topic to this video, and then we'll be finished. And then it's, where does it cross the x-axis? How do we find that? Where does it cross? And the answer is when f of x equals 0. So this is the f of x value. So that's the function. And f of x is the vertical. So if we cross the x-axis, that means f of x, or y, equals 0. So that's what this is. So the next quick topic is how to find where it crosses the x-axis. Okay, and so mathematically we call that finding the zeros of a function, which is, all it means is the x-intercept. But you can impress your friends by saying, hey, look, what are the zeros of this function? And that just means where did it cross the x-axis. Okay, and there's two basic ways to do this. One is called factoring, where you factor the quadratic equation, and then the other is where you use a quadratic equation formula, which is this. And I've even heard people sing songs how to remember that. I don't know it, but I've heard it. So let's look at some examples. So this one, this will factor. So remember, you set it equal to 0, and that's how you find the x-intercepts, or the zeros of the equation, the zeros of the function. So it factors into this, which then implies x is equal to 3. Now, the next one is this example. This also factors into x minus 9, x plus 1 equals 0. And then you set each of those equal to 0 and you solve for x, so that implies x is equal to 8 or x is equal to minus 1. And our last example is this one, and this is actually the graph that we did on the previous page. It doesn't factor, so we have to use the quadratic equation. X is equal to minus b plus or minus b squared minus 4 times a times c all over 2a. And it ends up equaling this. So remember, there's two solutions here, the minus and then the plus. And then if you solve that, you get 3.4 and x is equal to minus 1.4. And if you look on the previous page, you'll see that's where I drew the graph where it crosses here and here. Well, that's all I have today for quadratic functions. I hope you enjoyed the video. If you did, please like it and subscribe so you don't miss the next one. Thanks. Bye.